Refrigeration basics. This video talks about the basics of refrigeration. It includes the refrigeration cycle and function of the components, the vapor compression cycle used in the refrigeration system, and how your refrigerators work. Refrigeration is the process of removing heat from an enclosed space or from a substance in order to lower the temperature within that space or that substance. A refrigerant which has a low boiling point is used in this process to absorb or pick up the heat from anything inside the fridge and freezer and rejects that heat somewhere in order to pick up more heat and lowers the temperature of anything inside the fridge and freezer. The refrigeration cycle is an assembly of four major components, namely the compressor, the condenser, expansion valve, and evaporator. The refrigerant enters the suction line of the compressor at low pressure, warm vapor, not hot vapor. The main function of the compressor is to create a pressure difference between its suction line and discharge line and circulates the refrigerant around the system. It leaves the compressor at high pressure, hot vapor. In all of our discussion here, we will use the term vapor instead of gas because gas exists only in one physical state, that's the gas phase, whereas vapor can coexist with another physical state, vapor and liquid, like what is going to happen in this refrigeration cycle. At the compressor, the refrigerant vapor is compressed. The volume of refrigerant decreases, but all the molecules are still in there, although they are compacted or compressed. The pressure and temperature of the refrigerant increase, but the quantity is still the same. The refrigerant enters the condenser at high pressure hot vapor. The refrigerant is carrying the hot vapor from the compressor. The purpose of the condenser is to remove that heat from the hot vapor, thereby turning the vapor refrigerant into liquid, thus the name condenser. The hot vapor from the compressor enters the condenser coils. A fan blows ambient air to the hot condenser coils and dissipates the heat to the surroundings. This is known as convection. The hot refrigerant then loses its temperature and cools down. As it cools down, it begins to condense, turning from hot vapor into warm liquid, still at high pressure. Condenser is a heat exchanger, a heat rejector. There are fins attached to condenser coils to help dissipate the heat. The warm liquid refrigerant exits the condenser at high pressure. The warm liquid refrigerant enters the expansion valve at high pressure, warm liquid. Expansion valve is also called a metering device. This valve regulates the flow of refrigerant around the system. Its function is mainly to reduce the pressure and temperature of the refrigerant. Because the valve restricts the flow, less refrigerant flows through the evaporator. Thereby, there is more room for the refrigerant to expand. This is called flash vapor. As it expands, the molecules move farther apart and drops the temperature and pressure of the refrigerant. The expansion of the refrigerant gives more ability of that refrigerant to absorb or pick up heat. The refrigerant exits the expansion valve at low pressure cold liquid. At the evaporator, the refrigerant enters at low pressure cold liquid and passes through the evaporator coils. Evaporator is also a heat exchanger, the function of which is to absorb the heat from any substance. It is the cold liquid low pressure refrigerant that picks up the heat. The refrigerant absorbs the heat from any substance and lowers the temperature of that substance. When the refrigerant starts to absorb or picks up that heat, the refrigerant boils immediately because it has low boiling point. The refrigerant boils and will evaporate from liquid to vapor because the boiling point of the refrigerant is very low. For example, refrigerant 134A boils at minus 23 degrees Celsius. it doesn't take a lot of energy to boil a refrigerant. The refrigerant exits the evaporator as warm vapor at low pressure. It will then be sucked by the compressor and the cycle repeats. And the heat from the compressor will again be dumped at the condenser. Going back to the expansion valve, inside the valve is a diaphragm which is connected by capillary tubing to a thermostatic capsule at the exit of the evaporator. The change in pressure at the capsule travels along the capillary tube, and the change in pressure moves the diaphragm up and down. The up and down movement of the diaphragm allows less or more refrigerant to pass through. The pressure fluctuations sensed by the capsule at the exit of the evaporator regulates the amount of refrigerant to pass through the expansion valve. The temperature fluctuations sensed by the capsule at the exit of the evaporator determines the expansion or contraction of the refrigerant. Expansion of the refrigerant gives more ability of that refrigerant to absorb or pick up heat. Now let's talk about the two refrigerants commonly used before and currently used in refrigeration. Facts about refrigerant R22. R22, commonly known as Freon 22, was introduced in the 1950s. Its technical name is chlorodiafluoromethane, from the compound of hydrochlorofluorochlorocarbon. It's a colorless gas and boils at minus 40.8 degrees Celsius. The U.S. Environmental Protection Agency discovered that the use of R22 has a negative impact on the ozone layer. The United States discontinued its use since January 1, 2020. Here in Canada, R22 is being phased out due to its environmental impact. It has a high ozone depletion potential of 0.055 and a high global warming potential of 1,810. It contains chemicals that are unable to break down in Earth's lower atmosphere and thus will migrate to the stratosphere where they remain for years. Once they reach the stratosphere, they are broken up by UV radiation and speed up the natural decay of the ozone layer. So refrigerant 22 is now discontinued for use. Facts about refrigerant 134A. It is also known as Freon 134A. Its technical name is tetrafluoroethane. It is hydrofluorocarbon and haloalkane refrigerant. It's a colorless gas with a boiling point of minus 26.3 degrees Celsius. It is a non-ozone depleting refrigerant. It is a good replacement for R22, and it is a current standard for commercial refrigeration and car air conditioning. It is a potent greenhouse gas with a global warming potential of 1,430. It is the most common replacement for R22. Other replacements are R410A, R407A, and R47C. This is the vapor compression cycle used in refrigeration. Looking at the left diagram as a guide, from point 1 to 2 is the compressor, point 2 to 3 is the condenser, point 3 to 4 is the expansion valve or metering device, and point 4 to 1 is the evaporator. At the right is the chart for pressure and enthalpy for the processes involved in the refrigeration cycle, as the refrigerant passes through different components of the system. The refrigerant enters the compressor at point 1 as saturated vapor, meaning it's 100% vapor with no liquid content. An isentropic compression is done at the compressor. Isentropic means constant entropy. It is a thermodynamic process that is adiabatic and reversible. Adiabatic means there is no heat lost to the surroundings or heat gained from the surroundings. Reversible means that the compression process can continue even if the surrounding conditions are changed. At point 2 after compression, the refrigerant exits the compressor at superheated vapor conditions, meaning it is few degrees above saturated vapor at high pressure. As the hot refrigerant enters the condenser, ambient air is blown to the condenser coils and the hot vapor is turned into liquid at high pressure and high temperature. During the condensation process, the refrigerant pressure is made constant or isobaric. At point 3, the refrigerant exits the condenser at high pressure and saturated warm liquid. Saturated because it is 100% liquid with no vapor. At point 3, the refrigerant enters the expansion valve at still high pressure warm liquid. Expansion valve is also called a metering device or throttling valve. This valve controls the amount of refrigerant to be circulated to the system. Because the valve is restricting the flow, less refrigerant will flow, thus making more room for the refrigerant to expand to flush. The restriction at the valve removes pressure from the liquid refrigerant to allow vapor expansion. When the vapor expands, pressure and temperature drop significantly and the liquid changes its state from a liquid to a liquid vapor mixture inside the curved line. The expansion process is isenthalpic or constant enthalpy. Constant enthalpy means that there is no transfer of heat to or from the surroundings. No work is done by the surroundings or on the surroundings, and no change in kinetic energy of the fluid. Kinetic is the energy due to fluid in motion. Also, there is no change in energy entering and leaving the expansion valve. At point 4, the refrigerant leaves the expansion valve as a liquid-vapor mixture. Aside from regulating the flow of refrigerant, the expansion valve in the vapor compression cycle maintains a pressure differential between the low and high pressure sides. Low pressure side occurs at the evaporator and the high pressure side occurs at the condenser. From point 4 to 1 is the heat addition at the evaporator at constant pressure, isobaric. Heat from the substances is absorbed by the cold refrigerant. While the heat is picked up, the refrigerant boils and evaporates and turns from liquid to saturated vapor at low pressure. The refrigerant exits the evaporator at saturated vapor, low pressure, warm vapor refrigerant. It is then sucked at the suction side of the compressor and the cycle repeats. Now we come to the last item on how your refrigerators work. Have you ever wondered what's going on inside your refrigerator? Nowadays, most of our food items are stored in a refrigerator to maintain food freshness and to freeze meat, ice, fish, or even ice cream. The fundamental reason for having a refrigerator is to keep food cold. Cold temperatures help food stay fresh longer. The basic idea behind refrigeration is to slow down the activity of bacteria found in food so that it takes longer for the bacteria to spoil the food. In residential or commercial air conditioning, the purpose of refrigeration is to collect the heat from the rooms, heat from the occupants of the building, and then dump them somewhere safe. Inside your refrigerator, the compressor is located at the bottom of the fridge, and its job is to increase the refrigerant pressure and temperature. The compressor is also responsible for circulating the refrigerant around the system. As it compresses, the volume of the refrigerant decreases. The refrigerant exits as hot vapor, high pressure, and goes to the condenser. At the condenser, a fan blows a cooler ambient air to remove heat at the condenser coils and dissipate the heat to your kitchen. The fins help to dissipate the heat. The refrigerant exits the condenser and enters the expansion valve. The refrigerant enters the expansion valve or metering device at high pressure and expands or flushes into cold liquid in order to absorb heat when it reaches the evaporator at low pressure. The refrigerant then enters the evaporator coils to pick up the heat from anything inside the fridge. The refrigerant absorbs the heat given off by the things inside your fridge. This makes all your food items to be refrigerated either at the fridge area or at the freezer. The adjustment knob to control the temperature located inside your refrigerator is actually to regulate the amount of refrigerant flowing inside the evaporator coils. While picking up heat, the refrigerant boils and exits the evaporator as warm vapor at low pressure. The warm vapor refrigerant is then sucked by the compressor at low pressure and the cycle repeats.
If you think this is helpful information, please subscribe to Engineers Got Talent.